In this video, we'll be looking at the integrals of some specific and special functions. Specifically, we'll be looking at integrals of 1 upon quadratic kind of formats, 1 upon square root of quadratic kind of formats, and we'll also be looking at just square root of quadratic kind of formats. Without wasting much of a time, let's get going. Remember that whenever you see 1 upon x square plus a square, so there is a plus in between, the formula for this is 1 upon a tan inverse of x upon a. Okay, obviously there is a constant of integration, see the arbitrary constant. Okay, so remember, whenever there is a plus sign, it is 1 upon a tan inverse of x upon a, the integral of that particular function. Now whenever it is minus in between, whether it is x square minus a square or a square minus x square, instead of 1 upon a, you have 1 upon 2a in both of those cases whenever that is negative, and we have natural log in that case as well. Okay, so we have natural log mod of some numerator and some denominator. In the numerator and denominator, what we essentially have is the factors of that quadratic. So in case of x square minus a square, the factors are x minus a and x plus a. So you have x minus a and x plus a. I hope that makes sense. In case of a square minus x square, what you have is still the factors a minus x and a plus x. But since this is negative of this function essentially, so you have to write this factors in the reciprocal form. So you write a minus x in the denominator and a plus x in the numerator. I hope that makes sense. That's why the log property, we'll look at that when we prove these formulas. But for now, just remember that you just have to reverse or reciprocal of that factor. Whenever you have square root of x square plus a square or square root of x square minus a square, essentially the formats are similar. In both of the cases, you have ln modulus. You just write x plus this square root function, so square root of x square plus a square, and x plus the same function, square root of x square minus a square. Obviously, you will write arbitrary constant everywhere whenever you integrate. Okay, for now, just remember these formulas. In the following videos, we'll also prove these identities. So it will make even more sense. Whenever it is a square minus x square, so the constant is first, and then there is x square and there is a square root. Essentially, this is sine inverse of x by a. Obviously, plus constant of integration c. Now, the next set of formulas we have is just the square root of the quadratic function. Okay, so these are a little bit lengthier formulas. So there is a specific way in which, or a specific trick in which I like to remember. So remember that all the formulas of this kind starts with x by 2, and you just write the same function. Okay, so x by 2 square root of x square plus a square, and then again x by 2 square root of x square minus a square, then x by 2 square root of a square minus x square. So in this one there is plus. Remember, in case of x square minus a square, this is the only formula which out of all three which has negative, and remaining two formulas have a positive after this. Okay, and then you write a square by 2 in all of them, a square by 2, and we have some function which will get multiplied over here. Now, what function will get multiplied is really the integral of the reciprocal of this. So the reciprocal of this integral was ln x plus square root of x square plus a square. I hope that makes sense. Now, integral of reciprocal of this was ln x plus square root of x square minus a square, and integral of reciprocal of this was sine inverse x by a. Obviously, there is addition of arbitrary constant in all of those, but that's really the trick on how you remember these special formulas. These are the lengthiest integral formulas that you will see in your entire chapter, but that really covers all the special formulas that you will deal with in integrals, specifically of the type 1 upon quadratic or square root of quadratic or 1 over square root of quadratic. I hope that makes sense. If you understand the concepts that I'm teaching you, can I request you to like this video and subscribe to this channel? It is free for you, but it motivates me to create more such helpful content. Also, the PDF of this entire formula list is available in the description, so do check that PDF out. I do post math and calculus content every single day. That's another reason to subscribe. I'll see you tomorrow.